trying to stop you from finding this different information. And this chart was the gold standard that was there to show what human history was in terms of why things collapsed in the past. And because it disproved what the new CO2 was trying to tell you in the way it works is like CO2 drives climate. It's warmer now than ever. But this is the very best set they had from, the beginning of ice core drilling was this. They could reconstruct it by seeing the CO2 in it. And the CO2 levels were actually lower when the temperature was warmer in all of these spike events. So that disproved right there. And they're like, oh, we can't let anybody know. I mean, the CO2 was way lower and it was warmer then. That way we can't, that excuse everybody, even a kindergartner will see through it. That's my rant. Yes.
Right. Because they're blaming CO2, high CO2 levels on global warming. But if it was lower whenever it was hotter, then it doesn't make any sense. The whole thing falls apart.
And again, even the AI engines are built in to try to dissuade you from connecting all these small dots apart. Yeah, so anybody that's out there looking that, you can look this up. It's a GISP 2. Now, the ones in Antarctica also have their own data sets too that are very similar to this, but there was a disruption in their drill core or their core drilling, and nobody can really explain why. They just kind of stopped doing it down there. I'm sure you have more information about that than I do, but wherever you look, you can look at the Antarctic ice core drilling data as well. A little bit deeper in Antarctica, but for some reason, the ice is supposed to be so much thicker down there, but they never really got to the bottom like they should have. And I'm just asking why. Like, why didn't you guys reach rock layer down there? What did you touch or see or experience that made you stop drilling down there? That was the whole question about their drilling on some of the stations was like, why'd you stop? I thought the thing about science was to keep going, keep going. I thought you were going to hit bedrock somewhere down there and prove that the world was this, that, or the other. And they just locked it up, threw away the key, never to go drill another core down there, man. I don't know what happened, but.
Well, according to this Reader's Digest Antarctica edition, there is a 260 square kilometers, 100 square miles that has lakes, lush forests, greenery in the middle of Antarctica. I think that is the real mystery of Antarctica, is that there's a 100 square miles of lush greenery, lush forests, and lakes in the center of Antarctica. And they don't know why, they don't know how, and they've been studying it for a long time. I mean, on a supposedly frozen continent, for there to be 100 square miles of lush greenery and forested areas and trees and lakes is an anomaly, right?
The only two possibilities I could think that would make sense for that is a magnetic field line has established itself for an incredibly long time, highly electrified, that raised temperatures in that area. Or there is a volcanic breakthrough that allows heat to escape through that on multiple areas. Or perhaps the magnetic field line caused the volcanic breakthroughs, and those two are intertwined to allow a heated spot to exist within the ice that has some sort of barrier around it, because the positive pressure coming out can push away that cold air. Those neutrinos coming out of there too is a whole nother thing that, this intense neutrino emission coming out doesn't make sense either, unless there's some energy source down there. So you start to look at it. Admiral Byrd, I do believe, also talked about that on a couple of reconnaissance flights. There'd been several pilots that had talked about seeing this green area. So it didn't surprise me. It's not the first one.
That paragraph that I just read from there is connected to the Operation High Jump Admiral Byrd. That was the big discovery that they found in Antarctica, was this 100 square miles of lush greenery and forest.
Now, if I could throw another thing out there about that related directly to this, when we get into a more weakened magnetic field, we get more cosmic rays come in. These cosmic rays, energetic particles, they excite these different types of magma chambers. It depends what the magma is comprised of, what it's made of. So if it's made of silica, which everybody knows silica, crystals, this sort of thing, it's called silica-rich magma. When the cosmic rays come in, it gets excited. For some reason, that specific type of magma has like an amplified effect above any other types of liquid rock magma in our Earth's crust. Now, all along, if you look at a map of Antarctica, you see that large peninsula out there. Well, underneath those ice shelves, the volcanic activity has just ramped up tremendously in, say, the last 5 years. More or less, it did start around 10, 12 years ago. And it was getting warmer, and people were going to look at these punch throughs. They're starting to get like from beneath surface melting, not above surface, beneath surface. Right. It was changing water currents because the warm water was circulating at a different speed than the cold water. And they started to get these gyres and different things happening. Icebergs will break off and they would just spin. And like, well, that doesn't make sense. They should be moving with the current, not spinning and just stuck there. And there was a huge amount of ice anomalies. And I'm not going to say just like more or less sea ice. I'm just talking about when a part of an ice shelf would break off. It didn't behave remotely close to where they thought it would or how it would move after it broke off. Subsurface heating did that. So just remember, warm water and cold water move. The density is different and they move at different speeds. So there's a lot of things in that, like cold air and warm air, foggy air or clear air. You get all these different density differences in the way that things behave and move amongst themselves. So think about that for a second. What are they seeing or finding as these areas of ice are melted from beneath? Are they creating giant cavity and pockets? Because you got to think, okay, so Greenland ice is, 1.5 miles thick. If you had a volcano that was beneath that and melting away for, let's say, 1,000 years, but it was still cold enough at the top to keep the roof of it always frozen. So there'd be that boundary layer, that equilibrium point. Like how large could that cavern become heated from beneath the earth? And you got to suspect that the same thing would be happening in Antarctica. And that's maybe where your positive pressure is coming, because if that was an air-filled void, it would push out under the path of least resistance, but it would have more pressure than just the ambient atmosphere around it. Because if it vortices or, Schauberger vortex principles, you can speed water up to make it spin faster by just putting it in a circular motion. Well, with the same with air, and you think tornadoes spin slower. Why do they spin so fast? Well, Schauberger principles. So that pressure difference could be the reason you have the green there. But if the volcanoes are really kicking because of more cosmic rays, because we have a weakened magnetic field, then what is being melted and shown down there? Because before they're finding, way back in the day this is another thing that was, when they were doing the initial ice core drilling, like they came into some areas that weren't really that deep, that were, 1,000 feet deep, 1,500 feet deep, and they did hit bedrock, but they were finding, tropical fossils down there, things that were growing on the equator previously. All right, so that stunned them anyway. Like, what in the heck? Then we started to find all the same things in the Arctic as well as they started doing more research. But that's nothing, because all the tales, all of the stories, all of the accounts tell us that this has happened through history, that somehow they just found like, oh, well, wait, if you were to look at the old tales going back some 7,000 or 8,000 years through most cultures, they've talked about this, the repeating cycle of when it does this. So that's your first clue, history.
And 100 square miles is nothing to scoff at. That's a lot. That's a big amount of land that has lakes. And whenever they flew into this part, they actually landed on the lake. So the lake was big enough for a plane to land on the lake. That's a pretty big lake.
Yeah, it would be. And it just backs up validation that other processes are at work. Whether the greenery is there, whether there's cave melting from beneath, just the thing about the whole volcanic ranges and ridges inside all around the planet, anywhere there's silica-rich magma, are just going off the hook. Like these slow eruptions like we're seeing in Kilauea, which are starting to fountain off Etna. That's another one. Like we're really starting to see a lot of effects now of these, what were previously, I wouldn't say dormant, but slow oozing or barely, or they would take decades off at a time, or they're barely a smidgen, coming out. And now they're just roaring 3,000 foot tall fountains of lava.